welcome to this next segment in Introduction to C Programming. Today I would like to look at a specific data structure in C. In our last lesson we learned about the different types in C. We had discussed integer types, char types, and other various types. Today we're going to utilize the int type to understand arrays. So let's first look at how would you declare an array in C. So here you specify the type, and we could use something like A to represent the array, and then within brackets we would put in the size of the array. So let me go ahead and title this as array data structure. Okay, so this is how you declare it. And what is an array exactly? Well, let's try and draw a couple lines here. It's a block of memory that we could use to store some information. And it's a contiguous block of memory, so these would have memory addresses that would go in some sort of order. So that means all of the data is all going to be in a block of memory that's spaced one by one next to each other. And in it we could store things like numbers. We have declared it as an integer array, so we would store integers in there. And then we can do things with it like, we can have a multi-dimensional array, which is an array of arrays. So we could do an int array of arrays. So this will be going down this way. And then this one, so on and so forth. So basically we can make matrices with these. We could use these to store data about, some stream of data for audio input, or some stream of data from pixel input, whatever you want. The main thing is we can use this to store a block of information that we're going to use over and over again. So let's go ahead and see an example of coding an array. Here we are in Visual Studio Code. Let's go ahead and make a new folder here. We'll call it arrays. So arrays, add a new file, arrays.c, and a header file, array.h. In array.c, let's go ahead and include the standard libraries that we are using in this course, standard library.h, and for standard input and output, stdio.h. Okay, let's go ahead and just make sure that everything's working here, everything's kosher. So we'll go int main, and we'll go ahead and just print f hello and return 0. So quick review, you can press the control backtick, so that would be control backtick to alternate between the code editor and the terminal. So I'm going to press control backtick, and I'm now down here. You can see my cursor's down here. I'm going to go ahead and see, okay, so something happened in my directory here, so not a big deal. Let me just go ahead and cd into C drive, because I know that that's where everything starts for me, and then cd into intro. cd into intro. Okay, so something's wrong with my terminal. Not a big deal. If you do run into this type of issue, just go ahead and I'll get rid of that and I'll go ahead and open a new terminal. Not a big deal. Alright, I'm now in the terminal for Intro to C. So let's go ahead and ls and cd into arrays. And I need to save my file before I compile it. I'm going to use g++ array.c-o for output proc. Okay, let's just make sure this works. Yep, everything works. Okay, so now we're going to create an enumerated type up here. We're going to call it size. So we're going to use the keyword define, and we're going to call size 10. So that means that this word size is now associated with the number 10. So anytime that we use size, we're actually going to get 10. Watch here. Let's go ahead and put a %d in here, and let's put size in here. Let's go ahead and save it. Come back down to the terminal, and let's go up to the previous command. So we're down here, compile the code again, and then run proc, and we get 10. So it's like we can use this instead of using 10 because it's more readable. So now let's look at making an array type. So we're going to have A, and then in these brackets we're going to declare the size of memory that we're going to use. So that's our size. And the next thing I want to talk about is a for loop. So a for loop is a way for us to, well, before we even do a for loop, why don't we just take a step back? Let's just go ahead and assign something to the index. So we have an array. All right, this array's got 10 spaces in it. So we have 10 spaces in our array. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This would be index 1, index 2, index 3, or I'm sorry, arrays in programming always start with 0. That's really important actually. So we start at index 0, index 1, index 2, index 3, index 4, index 5, index 6, index 7, index 8, index 9. So our array is going to have these following indexes. And if we want to store something at 0, we would write a 0. Let's go ahead and say we're going to store the number 1 in there. A0, 1. What would our array look like at that point? We're going to have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are all going to be blank, and then we're going to have a 1 stored here. That's what our array is going to look like after we do that. Now, it'd be really nice if there was a way for us to be able to go through and assign numbers to all of these values, or I'm sorry, all of these spaces, and that's what we can do with a for loop. So a for loop will continue looping and iterating until a condition is met. Until a condition is met. So it's looping and iterating until a condition is met. In C syntax we use for. This is typically how you would write it. Int I, we're declaring a counter, we're setting it equal to 0. And we have really 3 pieces of code written in sequence here. Then we use some sort of condition like I less than 10, for example, is our condition. And then we use the postfix operator to increment that. So that means that we're going to loop over something until this condition is met. And if it's not met, we're going to add 1. That's what that means. That's what I++ means. So it means in the first iteration, I equals 0. Okay? And then I does not equal 10, so we're going to go through that line, and then we're going to do I equals, we're going to go through all of our code here. Then we're going to get I equals 1. And then I equals 1. Condition still not met, so we're going to go through all of our code. And I equals 2. Condition still not met, so I equals 2. Condition still not met, so I equals 3. All the way, blah, 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 until I equals 10. And then it's over. So let's go ahead and pop into Visual Studio Code and see how we can do something like that. All right. So first thing, let's just see what it looks like when we want to assign something to a particular index for our array. So I'm going to go ahead and say AI, or I'm not AI, A0 equals 1. Okay, so I've assigned 1 to the index 0. Now if I print out this data stored in the array, I can use %d for integer formatting, and all I have to do is just pass in the array at the index. So we're going to print out the data that's stored in the array at that particular index. So let's go down to the terminal, and we're going to run our previous command, g++ array.c -output proc, run it. Okay, so if everything worked correctly, we should see a 1 come out here. And not getting anything, and that's because we didn't save. All right, come back down, compile the code, proc, you get a 1. Great. Now let's see how we can store all of this. How can we store data into the indices of our array? So we're going to use a for loop. So for int I equals 0, I less than size I plus plus. I encourage you to pause the video here and try to understand what that line of code on line 10 is actually going to do. I encourage you to try and understand that those are really 3 pieces of code. We're declaring a counter and setting it equal to 0, and then we're setting a condition. As long as I is less than 10, we're going to increment I. Okay, we're going to say AI equals I. What's going to happen here? That means on the first iteration, we're going to store 0 at index 0. On the second iteration, we're going to store 1 at index 1, and so on and so forth. Okay, let's use the concept of a for loop to check what we have stored in the array. So we're going to do for int I equals 0, I less than size I plus plus, printf %d, and I'm going to use a line break here so that we get some space. So what that's doing is we're going to see a number with the %d, and then after that it's going to enter onto a new line in our print statement. And in here we need to give it the array, and then we're going to use I for the index because the first thing we want to print out is A0, the value stored at A0, then the value stored at A1, then the value stored at A2, then the value stored at A3, and so on and so forth. Let's go ahead and save that. Let's compile the code. And as you can see, we get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's store even numbers. So all I did was just multiplying I by 2, so it's going to give me even numbers. Let's save that and compile the code and then run it. Here we go. Now we just get even numbers stored in the array. All right, great. So we can do a one-dimensional array. Now let's look at how an application. of using a 1D array. A good example of an array, something that I know from mathematics, and at this point, if you want to come up with your own example that you can work with for using an array, that's entirely fine. I would say that if you're interested in electronics or you're interested in digital signal processing, we can start talking about the idea of a vector. Okay, a vector in math is a quantity that has magnitude and direction, and we represent it in mathematical notation, usually with some angle brackets, and then we have an x coordinate, a y coordinate, and a z coordinate. Okay, and so what does that look like? It would be like if we had a 3D plane. This is the x-axis, this is the z-axis, and this would be the y-axis. Well, these are the direction. These are the directions that we're going to have. We're going to have a I hat, j hat, and k hat. So we could write the vector like this in this notation, or we could write it as a x I hat plus y j hat plus z k hat. Okay, so I is going to be along. Whoop, did not want to do that. Let me go ahead and switch my pen. Looks like I'm only limited with this color here, so bear with me. We got I, K, and J along these axes. And so let's say we have the vector A equals 1I, 2J, 1K. That means we're going to go over 1 on the x-axis. We're going to go over 2 on the y-axis. So we're already out here. And then we need to go up just 1 on the z-axis. So we're going to end up here. So that would be a vector in 3 dimensions. Now the cool thing is we can do all sorts of calculus in 3 dimensions using a concept of a vector. Let's say we had another vector b, which was equal to, let's go with 2i and 1j and 2k. Not entirely sure what this is going to look like, so we're going to go over 2 spaces, so go over 1, go over 2 on the x-axis, and then go up just 1 on the j-axis. So we're going to have something that goes like this is what it's going to look like in the plane, and then up 1 and 2 in the z-axis, so it's going to go like this. And if we wanted to figure out what some relationship between these things, we could find the angle between these vectors. We could figure out what this vector is, so we find the angle theta between those two vectors, or we could figure out what the distances between these. We could use a dot product for that. So the dot product in math, we write it like a dot d, and this is going to be basically, you could think of it as component-wise multiplication. So we're going to have a x I times b x I plus a yj times byj plus azk times bzk. And what's going to happen is, just like in complex numbers, if you've seen them before, we can think of these unit vectors, like I hat. We can think of this as, the square root of -1 for all intents and purposes. So what happens is, when these two things get multiplied, they're just going to cancel out and give us +1, and then we're going to end up with this really cool equation. We're going to have ax bx plus ay by plus az bz. And that's going to give us the dot product of these two vectors. And there's special properties for the dot product. So if you want to be able to tell if both of these vectors are perpendicular to each other, so if they're perpendicular, then a dot d equals 0, and then if they are parallel, a dot d, well, depending on if they're unit vectors, let's just look at if they're perpendicular case. We won't discuss the parallel one. If you wanna see something about parallel vectors or whatever, I'll do a video on it. Just mention in the comments. I just want to create an application for using arrays in C. Okay, so we got this idea of a dot product. So we want to take this piece of information and encode it in C. So how can we do that? Well, first we got to create two vectors, int A size and int B size. And then in pseudocode, we want to loop through A, loop through B, and we're doing these first initial loops to assign values to it. And then finally, we're going to do loop through A, loop through B together, and do dot product dot product, just made a mistake here, dot product, and then print. We're going to go ahead and loop, and we'll need let's save a thing. We'll call it result, and then print result. So let's go ahead and pick an example that we will be able to check the answer and make sure that we're doing the math correctly here. So let's go ahead, and I'm going to clear this whiteboard. Let's go ahead and we're going to say that A equals 1, 3, 2, and B equals 2, 1, 3. Okay, so what is our dot product going to be? It's going to be A dot B equals 1 times 2, that's AX times BX, plus 3 times 1, that's AY times BY, plus 2 times 3, that's AZ times BZ. So what is this going to give us? 1 times 2 plus 3, that's 5, plus 6. So 5 plus 6, we're going to get 11. So our answer should be 11 if we code this. So that means our size is going to be equal to 3, and then we're going to do all of the the stuff that we just said, the pseudocode, and then we should get the answer. We should get the answer 11. So let's code this in Visual Studio Code. All right, let's go ahead and change a couple things here. So we're going to call this, we're going to make this into a 3, and we're going to, we can use some of this code actually. We're going to loop from 0 to 2. So we're going to go 0, 1, 2, and in AI, well, we're not going to really be able to loop over something like this. So let's just do this below. So we're going to take this line, and we're going to create another vector, and we're going to call it B. And we're going to do A0 should be equal to A0 should be equal to 1 from our example. A1 should be equal to 3. A2 should be equal to 2. Now we have B. B0 should be equal to 2. And B1 should be equal to 1. And B2 should be equal to 3. So in the pseudocode, I said that we'd have to loop over A and we'd have to loop over B. Well, we don't necessarily have to do that because we're just assigning the values here and here. Now, we do need to loop over A for the first part. So we have to loop over A. So this is one loop. And then we need to loop over B. Actually, if I look at this, we don't need to do that because we don't have, it's just a one-dimensional thing. We do need some place to store our result. So let's make a placeholder here called int result. Okay. So let's say that we wanted to multiply ax times bx. Here in C, we'd represent that with a0 times b0. And then we would want to store that in our result. But there's a problem with this. That's just going to give us a0 and b0. And then the next time we want to add to this a1 and b1. And then the next time we want to add a2 and b2. And then we want to stop after that and then print out the result. Oh, well, hang on. I starts at 0, then it becomes 1, then it becomes 2. So if we just start this with ai times bi, and then each time we add that to the result. So let's start a result from 0. And then the first time we're going to add to result a0 times b0. The second time we're going to add a1 times b1. And then the third time we're going to add a2 times b2. Then all we have to do is just print out a result. So I'm going to do result, and then I'm going to use the formatted string %d for an integer, and result. All right, let's go down to the terminal. I'm going to type clear to get rid of all that stuff. Now I just need to compile the code and then run it. And I get result as 11. Even further, let's go ahead and make a function up here at the top. So we'll call it int dot product. And it's going to take in int a, int b. That's our definition. And you know how I like to write my code. I took my definition and I put it down here. This is going to be where we're going to store the implementation. Now all we need to do is copy this. Oops. All I need to do is copy this, put that code in there, remove it from here. The other parameter that we should pass into our function here is result, or I'm sorry, is size. So let's go ahead and pass in int size. In a subsequent video, we'll look at how we can just get the size from these two arrays. But for now, the time being, we're just going to use size. And we need to manipulate our for loop here and change this into a size. Okay, now let's call this function. So we're going to have int a times b equals a times b, and then in the next line we're going to go a times b equals dot product of a, b, and then pass in the enumerated type size. And now we're going to do printf %d a times b. Save it. Now let's click down here in terminal, compile our code. Oh, get something. Warning, no return type. So the last thing we want to do here is return result. Our function has to return the result, and then that's going to get stored in a times b. So let's compile the code. And let's run it. And I get 11. That's the result. Even further, let's go ahead and copy this. Let's copy all this stuff here, and we'll put it in here in our header, and then we'll copy this stuff, and we'll put it here in our header, and we'll take these two guys. I don't even think, oh yeah, I'll need standard lib. In here, and then we'll do hash include array.h, save it, recompile it. Let's get rid of this. Save it, and we will recompile this, and then run it, and we get 11. Okay, so I hope that you found this really informative on not just C, but also a little bit of math, and we saw a real-world example of how we can go from some real concrete mathematics to implementing it into a program that we can use. If you enjoyed this video, please like my other videos, or check out my other stuff that I have going on, and please subscribe. Thank you. Bye-bye.